For the charity with the greatest percent of total expenses spent on programs, which is closest to the difference between actual and prediction? So if I look at the greatest percentage and follow over, that's this one. And if I look at the difference between predicted and actual, that's this distance here. So a distance from 85 to maybe 92, about 7. A particular forest had a mean annual temperature of -2°C. Based on the line of best fit, what would be the prediction? So if I follow, this would be about -2 here. If I go straight up, it's going to be just below 70, well, really close to 70. There's our answer. A piece of ice has a density of 920.4. If I plug that in over here for D, density, which is not really featured in the graph, I can solve this equation. First I'll subtract 918 from both sides. Then I'll multiply everything by 100, just to get rid of the decimals. Then I'm going to divide by -8, and x is going to be -30. I can plug this in and follow my line up and over to find the answer, which is going to be really close to 1.9. A line of best fit will be drawn for the data in the scatter plot below. So estimate, it's going to look something like this. It's going to be a positive slope for sure, so I can rule out A. And as I go over 1, I'm going up less than 1. So it's a fraction slope, so B is going to be my answer. C and D are too steep. Which of the following linear equations best fits the data? So if I estimate a line, I know that I'm going to have a positive slope, which all of these have, and I know that my intercept is going to be somewhere around in the 90s. Actually, no, because this part of the graph is for 5. So we don't see back for 0, so the best way to calculate this is going to be to find the slope. So if I pick two different points, let's say 6 and 7, how much am I increasing? 5, 10, 15, maybe 17 and a half or so. So it looks like 16 is a pretty good fit. I'm going to rule out A and B. And which one do you think is likely that for my intercept? That it's negative or that it's positive? Well, it's likely positive just because this is an actual data set. I could plug this in though. Let's say that I plugged in 6 into this equation. 6 times 15 plus 16. That would give me like 106, which is pretty close to this. If I did it with a negative, it would be nowhere close. So I'm going to go with D. For this line of best fit, how many data points is the Y prediction greater than the actual? So the actuals here are below the prediction for 1, 2, 3, 4, 5 points. For a swim that took 34 minutes, the actual is how much less than the prediction? So here's 34. If I follow that up, the actual is right here, 148, and the predicted is right here, 150, so it's the difference of 2. According to the line of best fit, which of the following is closest to the predicted increase in total fat in grams for every increase of 1 gram in total protein? In other words, they're asking for the slope of this line. If I pick a couple points, like this one, here and here, if I go right 20, I'm going up about 30. So 30 over 20 reduces to 3 over 2, or 1.5. Which of the following could be the equation of the line of best fit? Since my line is going up, I could rule out the negative slopes. Then let's look at two actual points. I have at 180, I'm at 90. So as I go right 20, I'm going up 10. So 10 over 20 is my slope, which is 1/2. Which data point has an actual Y value that is 2 more than the Y value predicted? So I see this one has 4 more, because the scale is 2. This one also has 4 more. But this one right here is my answer, 530. Another convenience store in the same state sells a 4-pack of AA batteries for $4.89. If the store's price is more than that predicted by the line of best fit, so $4.89 has to be above the line of best fit, what is the least number of competitors? So we want to be as far as we can this way, where we are still above this line. And there's our answer. 3. Because $4.89 has to be above the line of best fit. So for each store, we record the number of competitors and its price for a 4-pack of AA batteries. If the line 18, negative 12 is on this graph, or the line of best fit passes through it, well, is a convenience store ever going to charge negative $12 or negative $0.12 for batteries? So as we get too far to the right, the line of best fit will not model the price well. That's what the large number of competitors means. We're too far to the right and we're into the negative, so that doesn't make any sense.